Okay, so in this video, I'm going to show you how to do another U substitution example. And when you are doing your homework, you will get to a section of problems where it says that you should refer to example 5 in your textbook for a sample problem. So I am doing another example problem that is similar to example 5 in your book and that you could also use as a resource when completing those problems. Okay, so we're looking at the problem of the integral of x times the square root of 5x plus 1, and we have to find the antiderivative. So previously we discussed how your strategy on these is you want to identify what your u and your du portions are in the problem, and then replace everything in terms of u's and du's, and then integrate. Okay, and again, your strategy is you want to look for the inside function, because the inside function is what you want to use for your u. Okay, so when we're looking at this problem, we can see that we have the inside function of 5x plus 1. So I'm going to set that to be my u. So 5x plus 1 will be my u. Okay, so now when I go and I take my derivative of u, I get that du is equal to 5dx. All right, so now we look back at our original problem, and we have a little bit of an issue here, right? So we have a dx. The 5 is no big deal because we can multiply by 5 and divide by a 5 because that's just a constant. Okay, but the problem is that we still have this x, which we have not replaced with anything in terms of u yet. Okay, so we've got to be able to somehow replace x in terms of something u. All right, so when you look at what you have, you've got that u is equal to 5x plus 1. We have du is equal to 5dx. Okay, we want to rewrite everything that has an x in it in terms of u. So what we can do is we can take this u expression and we can solve it for x in terms of u. Okay, so if we do that, we end up getting that u minus 1 divided by 5, that's going to equal x. All right, so now we have a u expression which we can plug in for x, and everything else we already had covered, so we can go ahead and substitute in our u's and our du's. Okay, so when we go and we rewrite this problem then, we have 1/5 times the integral. Okay, in place of the x, we're going to substitute in u minus 1 over 5. And then we have the square root of u, and then du. Okay, so we've replaced everything in the original problem with something in terms of x. All right, so now you want to look at what you have left over and ask yourself, can you integrate this? All right, well, we have this 5 in the denominator. This we can just go ahead and pull out to the front because that is a constant. And then left over, we have this u minus 1 times the square root of u. Well, the square root of u is just u to the 1/2, so we can go ahead and distribute that. Okay, so we have u to the 1/2 times u, so that gives us u to the 3/2. And then we have u to the 1/2 times 1, so minus u to the 1/2 times du. Okay, and now you see we have a problem in which we know how to take the antiderivative of. Okay, so we'll go ahead and do that. So we have 1/25 out in front. And now for our antiderivative, we're going to have u to the 5/2, and then we'll divide by 5/2. So that's the same as multiplying by 2/5. And then we have u, that's going to be raised to the 3/2, and then we'll divide by 3/2, but that's the same thing as multiplying by 2/3. And then we got this plus c. Okay, so now we've taken the antiderivative. So now at this point, you would think, okay, I need to plug back in for my u. So all the way back from the beginning, we go back, we get our u expression, which was 5x plus 1. Okay, but by the time you're all done, you want to be able to have a simplified answer. So it's going to be much easier to simplify your answer now while you're still in terms of u, rather than substituting back in your x's and then trying to substitute. Okay, it's just a little bit of a cleaner problem. Okay, so when you look at what you have inside of these brackets, you want to pull out the greatest common factor. So I have this 1/25 out front. If I pull out the greatest common, I can pull out a 2/15. And then for my u's, I can take out u to the 3/2. Okay, and after I factored that out, left over from my first fraction, I end up being left with just a 3u. And then when I divide out, we have 2/3 divided by 2/15, that's going to leave us with 5. And then I'll go ahead and simplify the rest of the way. So out front now I have 2/375 times u to the 3/2 times the quantity 3u minus 5, and then plus c. Okay, so now I have everything simplified in terms of u. So I'm going to go ahead and now make my substitution back in. So I put my u expression of 5x plus 1 back into the problem. So I have 2/375. In place of u, I have 5x plus 1 to the 3/2. And then I have 3u, so 3 times 5x plus 1. So that's going to give me 15x, and then I have with the 5, that's going to leave me with minus 2 once you combine that with the 5. Okay, and there we go. So you have a completely simplified antiderivative function. Okay, so again, this goes with the problems in your book that say refer to example 5. Here's another example that is very similar to that. And the way that you'll see this addressed also is this is a complete change of variables problem. Okay, so I'll see you in class.